Hello and welcome to another video. In this video we're going to be working on find the winner of a circular game. And in this one there's n friends that are playing a game. The friends are sitting in a circle and they're numbered 1 to n in clockwise. And so you just move clockwise and then you move to the start after you do that. And you start the first friend and you want to count k friends in a clockwise direction, including the friend you started at. And then remove that guy once you get there. And then you start the next guy and you keep doing that. And you keep doing that until you have one person left. So return the winner. So in this first example, n equals 5 and k equals 2. So you're going to start over here. And then you're going to move up 2. So you're going to start here and then go here. So you're going to move this red guy. Then you're going to start the one after, which is 3. So you're going to go 1, 2, remove this guy. Then start the one after, which is 5. Then you're going to go 5, 1, remove that guy. Then start at 3 and remove 5. And you have 3 left over. And example 2 is much similar. So there is like a best way in terms of time, space and time to do this, but I think it's a little complicated for a medium problem, so instead I'll show you more practical stuff. So I'll talk about some practical solutions you can use and like the benefits of those. So one of them is pretty straightforward, and that's basically, so let's just go through that one. So with that one, let's say we have these people. So let's say this is our guys. And we don't have the 0. And then let's say k is like, let's copy this to use for later. Let's say k is like 3 or something. So what we can do is we can just say, okay, we're at some start index. Let's just jump to the one we're trying to get rid of. So we can just jump. Right, because we have an array, so we can just jump to the one we want to get rid of. And if k is bigger than the length of the array, we can figure out how much that is. Like if k is like 20, we can just mod our length of the array by that, or k mod the length of the array to loop around. So in O of 1, we can jump exactly where we want to be. So let's say it's here. Then we can just pop this element. And then we know we're starting at this index, and then from k we can calculate the index of the next guy just by doing a basic like index. And like I said, loop around, right? If this is 0, 1, 2, we know this is index 2, and then we can like loop around and so on. So you can basically kind of like remove these elements one at a time. And the problem with this is every time you pop an element, you're basically popping from the middle. So that is going to be expensive. So every time you pop, it's going to be n. Like, so it's going to be this, right? Because you have to pop n elements, and every time you pop, you can pop from the middle. So another approach you can take, instead of this guy, you can have a linked list instead. So let's imagine let's actually go back to this example. Let's say this is a linked list instead of, like imagine this is a linked list. I think singly or doubly would work. And let's say it like loops around here. So it all goes right, and then it loops around like this. So the way we could do it here is, like, let's say k is 3 again. And let's say we just have these elements, right? So let's just say we have 1, 2, I guess we can have one more. Yeah. So you can have a 3 over here. And this guy loops around. So every element is going to point to the one to the right of it. Maybe you can even make a doubly linked list. So something like this, right? I'm not going to like draw the circles, but this is basically what it looks like. So now what we can do instead is we can't go to a specific index because it's a linked list. But what we can do is we can start here, and we can say like, okay, well we need to go 3 times, actually twice, starting at the first element because you include the first element. So I'll go like twice, and then we can just get rid of this guy now. And because it's a linked list, you can do deletions in O of 1. So we can delete this guy in O of 1. And then we can go to like its next person and then start here and then, you know, go 1, 2. So you would actually go 2 every time because you count the number you start at. Then you delete this guy in O of 1. Gets a linked list. So then you'd start over here and then you'd go 2 more and then you delete this guy and so on and so on. So that's another way you could do it. And then eventually you can just keep track of like when I have 1 element left, let's return that. And so there, I'm basically kind of like brute forcing. So every time I actually have to manually move k times, but my deletion is n of 1. So that's n times k. But we can actually achieve the same thing with a linked list. We can just achieve the same thing with a queue. So once again, going back to, let's see if I have this saved. I don't. Okay. So let's just say we have this example again. And let's say every element is like this. So instead of this index, let's just say this is in the box. So if we know k is 3, again, and this is like another intuitive solution, and the rest of them are intuitive, so I won't explain those. So basically, we know we have to we know we want the third guy. So we can just say like if k is 3, let's just pop k minus 1, and let's bring those to the end. So we'll pop 1. So we have to pop 2 of them, right? We'll pop again. And every time we pop, we just put in the end. And now we have the guy we want to remove. So this is the guy we want to remove. Then we do the same thing. So we pop k minus 1 times, and we bring them to the end. And I think this is like probably the best solution that's intuitive. So we pop k minus 1, then this is the guy we want to remove. Then we do the same thing. So we're going to pop these two, and then remove this guy. Pop these two, remove this guy. Pop these two, remove the 8. And then pop these two, remove the 5. So we're going to have it like this. And then we have a couple more. So pop these two, remove the 2. And then we have 7 and 1. So it's going to go like 7, 1. Then we remove the 7. I think this is correct. Not exactly sure, but that's kind of the idea. So basically, you know you want the third guy. So we can just take the first 2 and just move them to the back in the same order. And we can keep doing that. And this is also n by k with O of n space. And I think this is the most intuitive. Then you don't have to make like a linked list or a doubly linked list. You can just use a basic queue. And so this is a solution we're going to go with. Like I said, there is like an O of 1 space-time solution, but I feel like that one's kind of like, if you haven't seen it, good luck. And it's just like some math problem thing, so I don't think it's super relevant for a medium problem, so I'm not going to go over that one. But we will code up this Q one because it's more practical for coding interviews, just practice Qs, and like this one is more reasonable to come up with. Like, how do I get rid of something from the middle? Well, I can just move things to the end until the thing in the middle isn't in the middle. It can just be at the front. Because you want to maintain the rest of the order in your array, basically. But you don't want to ever remove anything from the middle. So let's do that one. So we'll say, let's see, array dec integer, and we'll call this like circle. And then we want to put in numbers 1 to n. So we need like an add, I think. And this is I. Okay, so now our circle is going to be 1 to n. And now basically we have to keep doing this until our circle has 1 element left, and then we can return. So we can say like while circle, I think it's size, it's greater than 1. What we want to do is we want to take k minus 1 elements and move them to the back, and then we're going to pop the kth guy. So we'll say for 0 is less than. I wonder if you can do this in Java, because we're never using this value, so I wonder if we can do this as well. This is k minus 1. Like, I wonder if people actually do this. Maybe not. Looks like maybe it's invalid. Source level 9. Okay, so I guess you can't. Well, yeah, we're not using this value. So I guess there's like better ways of showing this in other languages. So yeah. Okay. So we're gonna basically say let's pop and let's add to the end. So we're gonna say circle add last. I guess add or add last, same thing. And then we need to pop from the front here. So circle, assuming, I mean, there's a bunch of things that do the same thing, I think, so I think this will work. So add, I think adds to the end, just in case, let's maybe add last. And then we can add last here too. Okay, so this should work for sure. It's essentially take the guy from the front, add it to the back, then pop the guy from the front. So circle dot pull first. Okay, that's the guy we want to remove, and then we just keep doing this. Then when we have one element left, we can just return circle. Is there an index? Is there like an at or something? To array. Oh, I guess we can just like pull first or whatever, right? Because it's only one element. So I think get first would work as well, because there's basically only one element now. Okay. So let's give that a try. I think there's a bunch of things in Java that do the same thing. So yeah, and you can see, so this is going to be like the linear and no space one, but I think that one's super intuitive, so I prefer this one, especially for a medium problem. So this one is going to be n by k and open space. And this is like pretty reasonable to come up with in a coding interview. So yeah, also let's see. Yeah. Okay, so hopefully you liked this one. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.